All right, so this is going to be a more complex problem here. A ball was shot straight up into the air with an unknown velocity next to a building. Mr. Tang is standing by a window that is 2 meters tall and whose bottom edge is 6 meters higher than where the ball was shot from. If the ball took 0.50 seconds to travel the entire length of the window, then with what velocity was the ball fired? Okay, let me try to draw out what I mean here. So we'll have the ground, we'll have a building, and then we'll have a window. Mr. Tang's in this window. Okay, so the window is 2 meters tall in length. Uh, 2.0. And then it says the bottom edge is 6 meters higher than where the ball was shot from. So the bottom edge of the window, I'll just go to the ground. We'll say the ball shot from the ground is 6.0 meters. So we're going to have a ball starting at the ground. It's launched up. And then 0.5 seconds. It took the ball 0.5 seconds to travel the entire length of the window. So for this 2 meters, this is 2 meters, and it took 0.5 seconds to go those 2 meters. And we're looking for the initial velocity of the ball, so v1 all the way down here is what we are looking for. So it's a pretty complex problem. There are clearly, I think, 2 sections to this problem. One is the first 6 meters that the ball travels, and then the next 2 meters that the ball travels. So when there's more than one section like that, what I like to do is make headings to organize my solution. So the first heading I will have is the ground to bottom of the window. All right, so there's a heading. I'm going to do some work there. But the other heading I'm going to have is just the window. So that 0.5 seconds and 2 meters where the ball is flying in front of the window. So what I'll do is I'll just make a list in each heading to see where I am. So I'll start with the window. The displacement is going to be 2 meters up. The time is going to be half a second. And the acceleration is going to be negative 9.8 meters per second squared up. So I chose negative up for gravity because my displacement is up. I already kind of set up as the main direction I'll be using. So that's why I did negative 9.8. Now, in terms of the first section from the ground to the bottom of the window, it's going to start off with some unknown velocity. That's what we're trying to find out. So that's where my question mark is going to be. It's going to travel 6 meters of displacement up before it reaches the bottom of the window. It will have an acceleration due to gravity as well. So negative 9.8 meters per second squared up. Okay, and I think that's all I really have. And how do I solve that for that V1 if I'm trying to use one of those big five formulas? Well, I actually can't yet because I don't have enough information. Usually when you're using the big five formulas, you need to know 3 numbers minimum before you can get that 4th number. And in the green section there, I only have 2 numbers that I know. So I actually need to figure out one more number that I can add to that list. Then I can go and figure out the question mark. So where am I going to get that last number? Well, there's actually a transition here. So from the red to the green section, maybe I should change the order here. Is that easy to do? Let's see. Oh, no. All right. So I will not try. I will abandon that attempt. The ball is going to have a certain speed v1 at the bottom. It's going to, I'll just use a highlighter here. Yeah, it's going to have a certain speed at the bottom. It's going to slow down, slow down, slow down, slow down until it gets to the bottom of the window. Then it's going to have some sort of speed, which I will call v2. That's actually going to be the same speed as the v1 of the window section. It's like a transition. So underneath the window section, I'm going to write v1 is a question mark. So if I can find out what velocity the ball had at the bottom of the window, that same number can be transferred over to the other section. So in other words, v2 in the green section will be equal to the v1 of the red section. I'll just call it the red section because I have colors, so it's easiest to do that. So that's kind of how I'm going to end up approaching this problem here. So I'm going to start with the red section and find that v1. So I look for the equation that deals with those 4 variables in that list, and that will be equation 3 right here. That's got all those variables in it. So delta D equals blah, blah, blah. I'll just copy it out. And with this, I'm trying to isolate for v1 here. Yikes, that's a lot of stuff moving around. Okay, I'm going to start by subtracting the half a delta t squared on both sides. And then after subtracting, I'll be left with v1 delta t. So I'm still going to have to divide both sides by delta t. And that will successfully isolate for v1. I'm going to go ahead and fill in those values now, and then put it in the calculator. Okay, so I'm just going to type this in the calculator here. It's easy to make a mistake here. I got to be really careful. Okay, so I'm getting 6.45. This should be to two significant figures, but I'm not going to round just yet because this is not my final answer yet, but I will underline to keep track of two significant figures. Okay, so that value, that V1, that's the starting speed of the window section, which I am going to transfer over now to become the V2 of the green section. All right, that is my third number that I have to work with in my green section. And now I pick an equation to figure out the V1. So that equation is it looks like it'll be this fifth one here. It's got all the variables in it. And I'm isolating for V1. So that's going to involve a subtraction of 2AD on both sides, as well as a square root. There should be a plus or minus, with the minus being inadmissible. Because I know my velocity is going to be positive. All right, so I'll fill in the values. So this is annoying because there's two sig fig rules to keep track of here, because there's a subtraction within a bunch of multiplying, dividing, and square rooting. Well, not dividing. So let me first deal with the 6.45. So that's a mistake, actually. I wrote 5.4. See, this is the advantage of rearranging the equation before subbing in numbers, because if you make a mistake, like I just did, at least all I have to do is fix one number. Okay, so if I start with 6.45 and square it, that's giving me 41.6025, and that's going to be to two digits. And the other part, so 2 times 9.8 times 6, it's giving me 117.6, and that's also to two digits. So now I do my subtraction step. Okay, something's not, okay, that's lots of mistakes here. That 9.8 should be a negative 9.8. And then a negative and a negative makes this plus. Okay, so I'll do an addition step. And when I do an addition step, I look at decimal places. So it looks like based on the 117.6, I need to round it to the nearest tens. So looking at the tens column. So I'll just underline up to the tens column there. And now I do the square root step. So square rooting is like related to division and multiplication. So I use that rule, which means I go to 2 sig figs. So I'm seeing 12.6 on my calculator here. So to 2 sig figs, that would round to 13. All right, 13 meters per second up is the answer I got. I'm actually not entirely confident because I did make a couple of mistakes in the middle of that, but hopefully at least the main ideas I got right.